Hey, we're going to do special senses. We're going to actually do the hearing and balance part of special senses here. So I wanted to start with the ear and talk about sort of the anatomical structures, and then we'll talk a little bit about how sound actually gets picked up. So the ear itself has three pieces to it. So this piece right here is the external ear. This piece right here is the middle ear, and then this piece right here is the internal ear. Now, the way this works is the external ear and the middle ear, they're involved only in hearing. But this piece right here, the internal ear, does both hearing and balance. So something to keep in mind as you're going through. So anatomically, the way that sound passes through your ear is it enters here, and this part of your ear is called the auricle or pinna. You can see auricle here spelled differently. There's no O. So sound travels through that. It travels through this opening. This is called the external acoustic meatus. That's also the name of the bone structure here in the skull. So this opening in the skull is the external acoustic meatus. And then it runs into this membrane. Now you probably know it as your eardrum, but it's actually the tympanic membrane. So the tympanic membrane is a sheet of connective tissue that vibrates. So a sound comes in, this thing vibrates, and it transfers these vibrations to these three bones right here. These are called the ear ossicles. Let me show you, here's a close-up of these ear ossicles. So these ear ossicles are the smallest bones in your body. These three have really cool names. So this one, this first one here, is called the malleus. The second one is called the incus, and this third one is called the stapes. So when the tympanic membrane vibrates, it transfers that vibration to these bones. Now, this third bone, the stapes, is actually attached to this structure called the oval window. And there's another membrane right here that attaches, we'll go back here, to the inner ear. So that membrane right here, this oval window membrane, is then attached to the inner ear. And this inner ear is actually filled with fluid, and that fluid vibrates along with the sound vibrations. So let's look at that inner ear, because that's where all of the detection is going on. So your inner ear, and let's look at this. Your inner ear is weird. Your inner ear has actually a couple different parts to it. This part over here that looks like a snail shell, I'm sort of wrapping around here. This is the cochlea. The cochlea is basically a long tube that's coiled up, very much like a snail shell. There's fluid in that opening. That fluid is called endolymph. That endolymph also travels around this part of the inner ear over here. This part of the inner ear has this region called the vestibule, and then this thing called the semicircular canals. And you actually have three of these semicircular canals. You have one in the transverse plane, one in the frontal plane, and one in the sagittal plane. And the fluid in here moves, and that's actually going to be used to detect motion. Now this part right here of the inner ear, the one that's the vestibule, that's actually going to detect your head in space, whether it's tilted, front, back, left, right. So I wanted to talk about how that is used, because that's used for balance. So I wanted to show you this. So if you look, this is a close-up of these regions. There's these sensory structures here in the vestibule. So there's fluid around them, but if you look at them up close, here's what they look like. So there's a layer of epithelium that lines this sensor, and then sitting on top of that is this jelly-like material. It's actually a gel, and sitting on top of that are these little crystals of calcium. It's called an otolith. So they're literally tiny little rocks made out of calcium stone. You have rocks in your head. And the way these rocks work is that when you shift your head, so if I tilt my head here like this, the otolith shifts and it pulls on this jelly-like material. And sitting in this jelly-like material, you have these processes coming off these cells called hair cells. Now we'll see hair cells, they're used for hearing and for balance. When these otoliths shift, these hair cells bend, they produce an action potential, they depolarize, produce an action potential, and your head picks that up as my head is tilting because this whole thing shifted. Try this. Next time you go around one of those big loopy exits on the highway, watch everyone else in the car, if you're not driving, and you'll see we all kind of instinctively tilt our heads because as you go around that curve, this otolith gets shifted and you feel like you're falling over. So that does head tilting. Now the other piece, these semicircular canals, they detect what's known as angular momentum. So if you spin, so if I turn my head like this, or if I were to do like a flip over this way, the fluid in these structures will actually move. So the fluid moves in the tube. And inside these tubes, you have another jelly-like structure. It's called a copula. And in that jelly-like structure, you have more hair cells. So when the fluid spins, this jelly-like structure moves, the hair cells bend, and they produce an action potential. And you pick that up as spinning. And this is why if you get off like a carnival ride where you've been spinning and you still feel dizzy, that's because this fluid is still moving in your ear. And that fluid then, even though you're not moving, that fluid moves and your brain picks it up as you're moving and you have that dizzy feeling. Now, the inner ear also does hearing, and hearing is very specifically done in the cochlea. So this image is a little weird. We're actually showing you a cross-section here of the cochlea. And so these things right here are actually the tubes that have fluid in them. So this fluid vibrates. Now, this middle part of the tube, which this image here, you're looking at a magnification of this tube. There's a region of this tube that has a structure in it. And we're going to zoom in over here. This image is a zoom in or a magnification of this image. You have these, again, hair cells, and these hair cells vibrate as the fluid, the endolymph in this structure vibrates. And you have these hair cells with different length hairs on them. And those different lengths pick up different frequencies. So the shorter ones pick up high frequencies and the longer ones pick up low frequencies. And as we age, these hair cells actually die. So as you get older, you lose the ability to hear high pitches. And that's why the olds love the bass in their music, because these things kind of die off. So it's sort of a review, because this is an important thing I will be asking you to do. As we walk through here, the sound passes through the external ear, through the auricle, and the external acoustic meatus. It passes to the tympanic membrane, to the malleus, the incus, the stapes, the oval window, and then to the cochlea. And inside the cochlea, it gets picked up by this sensory organ. So the sensory organ that you have in the cochlea is this thing called the organ of Corti. So here it is, this structure here called the organ of Corti.